I am John Christian Capasao.
I am I Kumawas.
I am Christian De Biraldino.
I am Vincent Nicoico.
I am John Paul Sade.
And we are here to present our topic, the muscular system.
Muscular system is the biological system of humans that produces movement. It's an organ system consisting of skeletal, smooth, and cardiac muscles. It maintains posture and circulates blood throughout the body.
There are three types of muscle tissue. The skeletal muscle, second, cardiac muscle, and lastly, smooth muscle. So, what is skeletal muscle? Skeletal muscle. This is a type of muscle creates movement in the body. Most skeletal muscles are attached to bones by bundles of collagen fibers known as tendons.
Major skeletal muscle groups. Forming the upper body are the abdominal, pectoral, deltoid, trapezius, latissimus dorsi, biceps, and triceps. Okay, game. Skeletal muscle groups forming the lower body are the quadriceps, hamstrings, gastrocnemius, soleus, and gluteus. Okay.
Under the major skeletal muscle groups that forms the upper body is abdominal muscles. What is abdominal muscles? Abdominal muscles they assist in the breathing process of accessory muscles of respiration. Moreover, their muscles serves as protection for the inner organs. Furthermore, together with the back muscles, they provide postural support and are important in defining the form. The next is deltoid. What is the function of deltoid? The function of deltoid is the contraction of the anterior fibers flexes and medially rotates the arm by pulling the humerus toward the clavicle. Then, the other one is trapezius. The function of trapezius are to move the scapulae and support the arm. And next is the latissimus dorsi. What is the function of latissimus dorsi? The function of latissimus dorsi is a synergistic role in extension and lateral flexion of the lumbar spine. And the other two, which is the last but definitely not the least, are the biceps and triceps. What are the functions of biceps and triceps? Its function is muscle with two heads, the large muscle. The last but not the least of the major skeletal muscle are biceps and triceps. A muscle with two heads, the large muscle at the front of the upper arm that flexes the forearm.
The major skeletal muscle groups forming the lower body is quadriceps. They are crucial in walking, running, jumping, and squatting. Because rectus femoris attaches to the ilium, it is also a flexor of the hip. Hamstring, cross and up upon joints and hip and knee. Gastrocnemius is a plant flexing the foot at the ankle joint and flexing the leg at the knee joint. Soleus and gluteus is plantar flexing the foot at the ankle joint and flexing the leg at the knee joint. And also gastrocnemius is primarily involved in running, jumping, and other fast movement of leg.
Structure of skeletal muscle. Each skeletal muscle is made of a number of muscle bundles of fascicles held together by a common collagenous connective tissue layer called fascia. Each muscle bundle consists of a number of muscle fibers. Each muscle fiber is lined by the plasma membrane called sarcolemma, enclosing the sarcoplasm. Muscle fiber is a synonym as the sarcoplasm contains many nuclei and mitochondria. The endoplasmic reticulum, that is, sarcoplasmic reticulum of the muscle fiber, is a storehouse of calcium ions. A characteristic feature of the muscle fiber is the presence of large number of parallelly arranged filaments in the sarcoplasm, called myofilaments or myofibrils. The myofibrils are staked in compartments, called sarcomeres. Each myofibril has alternate dark and light bands on it. The study of myofibril revealed that this striated appearance is due to the distribution pattern of two proteins, actin and myosin. Both are contractile proteins. Both the proteins are arranged as rod-like structures parallel to each other and also to the longitudinal axis of the myofibrils. Actin filaments are thinner as compared to the myosin filaments, hence are commonly called thin and thick filaments. In the center of each eye band is an elastic fiber called Z-line which bisects it. The thin filaments are firmly attached to the Z-line. The thick filaments in the A band are also held together in the middle of this band by a thin fibrous membrane called M-line. The A and I bands are arranged alternately throughout the length of the myofibrils. The portion of the myofibril between two successive Z lines is considered as functional unit of contraction and is called sarcomere. In the resting state, the edges of thin filaments on either side of the thick filaments partially overlap the free ends of the thick filaments, leaving the central part of the thick filament. The central part of thick filament not overlapped by thin filaments is called the edge zone.
Muscle. What is cardiac muscle? These are muscles of the heart and lungs. They are self-contracting, automatically regulated, and must continue to contract in rhythmic fashion for whole life of the organism. It is very important job is to pump the blood through the myelin of blood vessels in the body.
The Cardiac Muscle Cell by Maren Owens. The cardiac muscle cell is a Y-shaped cell found in the heart. It is striated, which means you can see the dark and light spots of the cell. One of the main parts of the cell are the intercalated discs. These discs help hold the cell next to them together using desmosomes that act like adhesion, and help send quick actions to each chamber, allowing them to contract together. Gap junctions, which are inside of the intercalated discs, are the passageways for the actions to pass through. Unlike skeletal and smooth muscle, which are two of the three muscles in the body, cardiac muscle cells branch off from each other using the intercalated discs. As you see in the picture, the T-tubules, also called the transverse tubules, are there to send the impulse of the contraction to inside the cell. The sarcoplasmic reticulum that you see in the top right corner releases calcium ions when the cell contracts and takes them in when not. This picture shows some of the locations where the skeletal and smooth muscle cells are. The skeletal muscle attaches to the bones for the movement of our body. The smooth muscle cells are mostly surrounding hollow organs like the stomach, bronchi, and esophagus. The skeletal and cardiac muscle cells are somewhat alike because they are both striated. The cardiac cell is more looked upon in a way. The heart is known for pumping blood throughout the body and is more resistant to fat because of the high energy that is produced inside the mitochondria, myoglobin, and the blood supply. Although the heart is controlled by the autonomic nervous system, it can still function without it due to the pacemaker cells. These cells can still contract because their cell membrane allows potassium and sodium to pass through that causes one cell to contract to trigger the rest of the pacemaker cells to set off. This is why the cardiac muscle cell is specialized. This is a picture under the microscope of the cardiac muscle cell. The dark pink vertical lines that you see are the intercalated discs. The circular purple spots are the nuclei, and the lines you see that are vertical is showing how the cells are striated. And this is what you need to know about the cardiac muscle cell.
Smooth muscle is the type of muscle that makes up the walls of many internal organs and structures. You will find this type of muscle in your digestive tract, blood vessels, and blood bladder. It looks like smooth sheets of muscle. The main function of the smooth muscle cells is to help hollow organs contract.
Many diseases that occurs on muscular system, we choose the muscle atrophy. The alternate names are atrophy of the muscle wasting, and wasting. The majority of the muscle atrophy in the general population results from disuse. People with sedentary jobs and senior citizens with decreased activity can be lose muscle tone and develop significant atrophy. This type of atrophy is reversible with vigorous exercise. Bedridden people can undergo significant muscle wasting. Astronauts free of gravitational pull of Earth can develop decreased muscle tone and loss of calcium from their bones following just a few days of weightlessness. Thank you for
The number one fatal disease for children under 2 is spinal muscular atrophy. So what is spinal muscular atrophy? It's the loss of ability to perform daily life functions like walking, eating, and breathing. Apoptosis leads to cell death in the spinal cord when there is a lack of a specific protein. It was discovered in 1890 by Verdick and Hoffman during a procedural autopsy. So where does it come from? It's located on chromosome number 5 at the SMN1 gene. This codes for a protein, and when it is lacking, spinal muscular atrophy can occur. Well, how can one get it? It is a rare genetic disease affecting 1 in 50 Americans. Can it be inherited? With 2 carriers, there's a 25% chance of having an affected child. How can you tell if someone has it? When people don't reach developmental milestones, spinal muscular atrophy is a diagnosis some people consider. Symptoms are dependent